Welcome to the Complex Numbers series of our Maths module. For this first episode, we're just going to go over a few concepts for complex numbers and show you what they are. So first we need to address I and j. You'll see both of these used for complex numbers, and everyone treats both of these to be equal and for them also to be equal to the square root of -1. It should be noted that I and j are actually different. That will be addressed later on in the series, and for now I'm going to be using I as opposed to j, and I'm going to be treating I as equal to -1. As I is equal to the root of -1, I squared equals -1, I cubed is minus I, and finally I to the 4 is 1. So we can go through a sequence, increasing the power by 1 each time, and from 4, if we increase it by 1 again, we return back to I. A complex number is normally given, in fact you'll mostly find always to be given, in terms of z, and is equal to some value, a, plus I, b. You may see it just be given as z equals I something, or you may see a complex number actually just be given as a single value. But if we're dealing with complex numbers, we should also know that that means that this has some value 0 on the first, and on the other one it has I by some value 0. So if you're ever asked to give an answer in terms of a plus ib, don't forget the zeros because you may lose marks in an exam. But that is how a complex number is normally represented. Finally, for this introduction, we're just going to go over a few different things with complex numbers. We have something called a complex conjugate, where if we have a complex number z, and z, in this case, we're going to assign it the values 3 plus I4, and we have another number, z2, which is going to be equal to 1 minus I5. If we were to take the complex conjugates of these numbers, where the complex conjugate is given in two different forms. It can be given as z bar, where we just put a bar over top of the z, or it can be given as z with a superscript star on it. They call it superscript star. There are two ways it's always referred to. I like to use the z bar as it's far easier to write down. So if we were going to give a complex conjugate for these two numbers, we take z bar, and what we do is we look at the first term. This is the real term, and we just write that normally. And then for our sign between our two terms, we reverse that. So we get minus I to the 4. And for z2 bar, we get 1, and again we reverse our sign, plus I5. We'll address a few more things. If you're asked to give the real, and that will be just denoted, as you'd expect, something like the word real, so RE, you'll have square brackets, and usually then just give you Z. It could be Z2, but we're going to use Z in this case, and this would just be the real part, which is 3. And then the imaginary part, here, of Z is 4. You have 4i there. We're also going to look at now the magnitudes. So the magnitude, we'll show later where this comes from when we're addressing polar coordinates, but quite simply the magnitude is denoted by the modulus symbol and is given as the root of the real term squared plus the imaginary term squared. If you think of this as in trigonometry, that would be a c equals the root of a squared plus b squared. And that's all we're going to cover for our first introduction, a few things, and we're going to look at how we use these next.